Hello student, Jai Swaminarayan. Today we continue with the remote sensing application for flood mapping. Near real-time monitoring of the flood in case of the flood in India using the satellite remote sensing techniques. Maps showing the flood affected areas and flood damage statistics in near real-time are provided by NRSC. In addition, using the different sources of information, the rainfall activity and subsequent flood conditions are monitored on a daily basis. Different sources of rainfall activity then subsequent flood condition are monitored on the daily basis. Okay. तो रिमोट सेंसिंग एप्लीकेशन की मदद से आपको पता चल सकता है कि भाई फ्लड अफेक्टेड एरियाज कौन सा है, फ्लड डैमेज कितना हो सकता है रियल में. ओके वो इंफॉर्मेशन से पता चलता है. देन यूजिंग द डिफरेंट सोर्सेस ऑफ इंफॉर्मेशन, रेनफॉल एक्टिविटी की कहाँ पे कितना रेनफॉल हो सकता है. ओके सबसिक्वेंट फ्लड कंडीशन आर मॉनिटर्ड ऑन द डेली बेसिस. फॉर एग्जांपल, इंडिया मेट्रोलॉजिकल डिपार्टमेंट प्रोवाइड्स climate and rainfall related information, numerical weather prediction models etc. which help in generating the flood warning as well as the flood management. तो ये डिपार्टमेंट है, वहाँ पे आपको क्या प्रोवाइड करता है, क्लाइमेट एंड रेनफॉल रिलेटेड इंफॉर्मेशन प्रोवाइड करता है, जिसकी और वेदर कैसा है, कहाँ पे बारिश हो सकती है, कहाँ पे फ्लड आ सकता है. ओके तो वेदर के रिलेटेड आपको डेटा मिलेगा, उस पे से पता चलेगा कि यहाँ पे फ्लड हो सकता है कि नहीं हो सकता है, और फ्लड आया तो उसको कैसे मैनेज करें. Also, the near real-time meteorological data from the Kalpana 1 image are used to study the cloud cover, hence to indicate the possibility of the heavy rainfall flooding under the certain situations. High resolution rainfall data is also available from the TRMM, which may be used to tune the hydrological models to arrive at better prediction, facilitating the near real-time monitoring of the floods. Figure shows the infrared images obtained from the Kalpana 1 on 17 June 2013, which shows thick cloud over the Uttarakhand region, and the heavy rainfall that occurred subsequently caused the heavy flood damage in the area. तो यहाँ पे फिगर है जिसमें उत्तराखंड जो एरिया है वहाँ पे हैवी infrared image obtained from the Kalpana 1st and 17 June. Okay, linear sketch projection MIR. ओके तो यहाँ पे जो इमेज है उस पे से हमें पता चलता है कि भाई कहाँ पे हैवी रेनफॉल होने वाला है. ओके इन उत्तराखंड एरिया. Flood damage assessment. Flood inundation maps may be used for the assessment of the damage caused due to the flood, overlaying the administrative boundaries and the land use. Land cover map helps to identify the properties damaged due to the inundated water, crop areas, submerged damage caused to the rail and road network. ओके कहाँ पे कितना डैमेज होता है वो हमें रिमोट सेंसिंग इमेज पे से पता चल सकता है. फिगर शोज द फ्लड इनंडेशन मैप्स ऑफ द ब्रह्मपुत्र रिवर फ्लड दैट अकर्ड इन जुलाई 2003. फ्लड इनंडेशन मैप्स आर ऑब्टेन्ड बाय overlaying the village and town boundaries as shown in the figure. Thus the aerial extent of inundation and the villages affected can be easily identified in the map. DSC provides this flood damage assessment report within 5 years after the data acquisition. Okay, flood inundation Brahmaputra river and Guwahati. तो आपको ब्रह्मपुत्र रिवर है तो यहाँ पे फ्लड, ये फ्लड इनंडेशन एरिया है. ओके और कहाँ पे इतना, यहाँ पे इतना फ्लड आया, यहाँ पे फ्लड आया है, यहाँ फ्लड आया है, दैट इज फ्लड इनंडेशन एरिया. ओके द फ्लड हैजार्ड मैपिंग. The flood hazard map of an area shows the area likely to be inundated during the floods of different magnitudes and with specific return period. Such maps helps to identify the area most vulnerable to frequent floods. Appropriate measures can be taken to, that means frequent बार बार वो फ्लड आने की संभावना है वो एरिया हम उसका मैपिंग कर सकते हैं. Approximate measures can be taken to regulate the development activities in such areas so as to minimize the damage in case of the flood. Remote sensing data can be used to identify the flood affected areas continuously over a long period. Figure shows the flood hazard map represented by DSC for Brahmaputra river basin in Assam. Flood inundation information collected using the satellite remote sensing data for the period of 1998 to 2000 was used for generating the map. वेरी लो, मॉडरेट एंड हाई फ्लड. यहाँ पे फ्लड हैजर्ड्स वेरी हाई, तो यहाँ पे पिंक कलर से दिखाया हुआ है कि यहाँ पे हाई फ्लड आ सकता है, वेरी हाई फ्लड आ सकता है. दैट ये येलो कलर से यहाँ पे दिखाया गया है, येलो कलर से दिखाया गया है, येलो नहीं है ब्राउन है, ब्राउन कलर से यहाँ पे आपको दिखाया गया है कि यहाँ पे हाई फ्लड आ सकता है. अलग अलग कलर्स यूज करके आपको दिखाया गया है कि यहाँ पे ज़्यादा फ्लड आ सकता है, कम फ्लड आ सकता है, क्या फ्लड आने से कौन सा नुकसान हो सकता है, यहाँ पे ज़्यादा फ्लड आने से ये नुकसान हो सकता है, वो सब हमें यहाँ पे दिखाया गया है. River studies, mapping of the river bank erosion, river course change, etc. The satellite remote sensing data have also been used for analyzing the changes in the river morphology, embankment, breach, river course change, etc. तो फ्लड आने से क्या होता है, रिवर का जो भी बैंक है उसमें चेंज होता है. ओके, उसका जो भी क्रॉस सेक्शन वगैरह होता है उसमें चेंज होता है, तो कौन सा चेंज आया है वो दिखा सकते हैं. ओके, बिकॉज रिवर बैंक इरोजन होता है, उसकी वजह से क्या होता है, उसके उसका जो भी स्ट्रक्चर होता है उसमें चेंज होता है, कॉज्ड बाय द हाई इंटेंसिटी ऑफ द फ्लड वेव्स. द post-flood satellite data can be analyzed to delineate the active river channel and river bank lines. This may be used further to determine the extent of the erosion or deposition. Figure shows the map of Kosi River embankment in 2007 and in 2008 derived from the satellite images. Map of the 2008 shows the embankment breach on the Kosi River that occurred in 2008. The Kosi River burst through its earthen embankment about 13 km upstream in Nepal, thereby running through a new course 15 to 20 km wide. Conclusion: the remote sensing data have a very good potential in aiding the flood monitoring and mitigation studies. Okay, यहाँ पे आपको क्या दिया है, रेफरेंसेस दिया है जिसकी मदद से आप क्या कर सकते हो. इस पे से जो भी ये पेपर बनाया है, ओके, और ये जो भी इंफॉर्मेशन दिया है और लिया है, ओके, जो भी इंफॉर्मेशन लिया है वो इसका यूज़ करके हमने इसका यूज़ करके ये पेपर बनाया हुआ है. ओके, then next, remote sensing application in the drought management. Introduction: drought is a phenomenon of long-term moisture deficiency. It may be meteorological, agricultural, and hydrological drought. Meteorological drought indicates the deficiency in the precipitation, whereas agricultural drought indicates the scarcity in plant water availability, leading to a reduction in crop yield. Okay, मेट्रोलॉजिकल ड्राउट यानी क्या, जो भी प्रेसिपिटेशन होता है वो कम होता है, उसमें डेफिशिएंसी होती है। दैट मीन्स प्रेसिपिटेशन यानी रेनफॉल होना चाहिए वो नहीं होता है, दैट इज कॉल्ड मेट्रोलॉजिकल ड्राउट। देन एग्रीकल्चरल ड्राउट यानी क्या, प्लांट वाटर जो भी अवेलेबल होना चाहिए वो नहीं होता है, उसके वजह से क्या होता है, क्रॉप यील्ड कम होता है। Then hydrologic drought is defined using a combination of factors such as stream flow, then groundwater availability, reservoir storage, that is called hydrologic drought. Then remote sensing methods have been used for monitoring both the agriculture and meteorological drought. This lecture gives a brief introduction to the application of remote sensing methods for drought monitoring, particularly agricultural drought monitoring. The lecture gives the details of National Agricultural Drought Assessment and Monitoring System initiated by the National Remote Sensing Agency, India. The remote sensing application in a drought assessment. The remote sensing application in drought assessment involves monitoring of both the meteorological condition and agronomic condition. What do you understand by meteorological condition? So, remote sensing techniques have been used very effectively to estimate the rainfall and solar radiation, which are some of the essential information for the drought forecasting and monitoring. The remote sensing estimation of the rainfall is based on the differentiation of the precipitating clouds from the non-precipitating clouds. Optical remote sensing techniques and microwave have been used for this. Solar radiation is a major determinant of plant growth and evapotranspiration. Remote sensing techniques are being used to measure the solar insolation through the measurement of the energy reflected back from the area. Then agronomic condition. Agronomic condition यानी क्या, तो मेट्रोलॉजिकल कंडीशन में क्या होता है कि आपको पता चलता है कि भाई कहाँ पे प्रेसिपिटेटिंग क्लाउड है, नहीं है, कितना रेनफॉल हो सकता है। ओके, तो उससे से हमें पता चलता है कि दैट इज कॉल्ड मेट्रोलॉजिकल कंडीशन. Then agronomic condition. The remote sensing data have been widely used to monitor the crop health condition. Remote sensing derived indicates such as NDVI are generally used for this. In addition, the daytime and nighttime thermal data have been used to find the thermal inertia of the system and hence to interpret the moisture stress condition. तो कहाँ पे जो भी क्रॉप हेल्थ कंडीशन, क्रॉप की हेल्थ कैसी है, वो अच्छा है कि नहीं है, उसको प्रॉपर पानी मिल रहा है कि नहीं मिल रहा है, कोई जगह पे मॉइस्चर की कमी है कि नहीं है, दैट इज कॉल्ड एग्रोनॉमिक कंडीशन. Another major application of the remote sensing is in the estimation of the soil moisture condition in the field. National Agriculture Drought Assessment and Monitoring System, that is called NA, the National Agriculture Drought Assessment and Monitoring was initiated in this by National Remote Sensing Agency under the Remote Sensing Application Mission Drought Monitoring Program. The project covers 14 states of the country which are agriculturally important and valuable to the drought, and the states covered under this system are Andhra Pradesh, Bihar, Chandigarh, Gujarat, Haryana, Jharkhand, Karnataka, Maharashtra, Madhya Pradesh, Orissa, Rajasthan, Tamil Nadu, Uttaranchal, Uttar Pradesh, etc. This system provides near real-time information on the prevalence, severity level and persistence of the agriculture drought at the national, state, district level during the Kharif season. Initial objective of the program were to provide the periodic drought monitoring at the district level during the Kharif season. With the advancement of the technology and the objectives have been modified, and currently mission provides drought monitoring at the district level for the entire country. In addition, river basin wise, crop wise, comprehensive drought monitoring is also achieved under the mission. The details of this system shown in this lecture are mainly from the work done by Dr. A.T. Jayasalan and his colleagues in this NRSA Hyderabad. Drought assessment under this system shows the conceptual of various droughts in the system. Accordingly, agricultural drought is assessed by measuring the crop biophysical parameters and in turn the vegetation index and yield condition through the remote sensing. In this system, vegetation indices derived from the remote sensing data have been used to assess the drought severity. Okay, vegetation indices is also used to derive the other relevant parameters and weighted average vegetation index over entire geographical area of each district. Okay, drought assessment in any reporting period is based on the comparison of the district and DVI profile till then to the seasonal profiles of the normal year. For example, figure 3 shows the profile for the Sikar district in the Rajasthan. Okay, greater than 10% है तो better condition है crop yield के. Okay, crop की profile anomalies are interpreted in terms of moisture, stress condition, relative severity level. Okay, drought assessment methodology consists of two components of two segments, ground segment and space segment. यहाँ पे profile anomalies are interpreted in terms of moisture, stress condition and relative severity level. The relative drought severity level, normal, mild, moderate and severe, is assessed on the basis of criteria such as delay in the vegetation growth, okay, and compared to normal year in percentage, कितना वेजिटेशन ग्रोथ में डिले हो रहा है वो सब इसमें से पता चलता है. ग्राउंड सेगमेंट, द ग्राउंड सेगमेंट कंसिस्ट ऑफ कलेक्शन एंड एग्रीगेशन ऑफ द ग्राउंड बेस्ड इंफॉर्मेशन पर्टेनिंग टू द लैंड यूज कंडीशंस, crop particulars such as cropping pattern, crop duration, yield, irrigated and rain feed area identification. Is also consist of derivation of the correlation between the vegetation intensity and the crop yield. The historic ground and satellite data, land use, crop particulars and irrigated or rain feed. तो crop calendar, cropping pattern, crop yield क्या है वो पता चलता है. Then उसमें model development, rainfall, then this and development of EI interpretation case. Okay, space segment, the space segment consists of generation of the NDVI images, district level statistic extraction, drought assessment, integrating the satellite and ground segment informations. Remote sensing data used in the NADAMS in view of the whole country coverage and periodic reporting of the every fortnight. System uses National Ocean and Atmospheric Administration satellites advanced very high resolution radiometer data that has 1.1 kilometer spatial resolution at nadir and everyday revisit capability. The advanced very high resolution radiometer data is used for the drought monitoring in the 10 states marked in figure. The remaining 4 states are monitored by the another data. This WIFS or YFS data. Detailed drought analysis at sub-district level is achieved for 4 states. Andhra Pradesh, Karnataka, Haryana, Maharashtra by using moderate resolution advanced wide field sensors and sensors of resource set. The raw satellite data are collected from the respective organization, and the basic corrections, geometric correction, radiometric correction, panoramic corrections are made. Further, the data is used to extract the vegetation indices as well as the land surface temperature. Okay, thank you.